Hi, this is Unit 9, and this is our first topic in Unit 9, and it's all about analyzing a quadratic function. So, quadratic functions always look like this graph in the middle. And what we're going to do first is there's something missing on this graph. I want you guys to sketch in arrows on both sides. To describe this graph, we say that it's a U shape. It looks like a letter U. It's rounded at the bottom, and it goes on forever on both directions. The first thing I want you to do is actually look at this shape, and I want to plot some points where they belong. So I'm going to plot points. There's points all along this graph. I'm going to pick the values that actually have points that are on the grid lines, and I'm just going to put points there. Okay. Alright, so that's the good thing. I just want to do that to start. The other thing I want to do is I want you to notice something about this graph. If you look at this graph, there is a left side of the graph and a right side of the graph, and they look like mirror images of each other. So what I want to do is draw a dotted line right down the middle of this graph. And what that does is it separates this graph into a left side and a right side. Alright, so now we're going to go around this web. I'm going to start up here at the front. The top of this says that this function in factored form, factored means that I have these two sets of parentheses, is x minus 2 times x plus 4. And it says to multiply to write this in standard form. And it gives me a big hint here to use the box method. If I want to multiply those two factors, I have to do this. X and minus 2, that comes from here. And then x and positive 4, and I'll fill in the inside. X squared minus 2x, 4x, negative 8. I have like terms inside the box, here and here. So when I write my final answer, I'm going to keep f of x. All right, f of x equals. These two things multiplied are what's inside the box. X squared, combine my like terms, and I get positive 2x and then minus 8. So these are two different ways to write the same exact equation. One is factored, one is in what's called standard form. Alright, so now we're going to move around here. I'm going to start at the top left. It says x-intercepts. X-intercepts, the definition is where the graph crosses the x-axis. There's another word for those. We're going to call them zeros. That word we're going to use interchangeably. Sometimes we'll say x-intercepts, sometimes we'll say zeros. The zeros, we have them on our graph. We already actually sketched them. They're here and here. So I'm going to label those. They are negative 4, 0, and positive 2, 0. All right, let's go down right to the y-intercept. The y-intercept is the same thing, except we're talking about the y-axis. So look over at your graph. This is the y-axis. My graph crosses the y-axis right here at 0, negative 8. One thing to note is it's very important where this 0 goes. X-intercept, I know the x value. Y-intercept, I know the y value. Okay, next let's talk about axis of symmetry. Axis of symmetry is an imaginary vertical line that splits the graph into two symmetric pieces. We actually already drew our axis of symmetry. It's this dotted line right here. It splits our graph. So our axis of symmetry, I'm going to write it down here, axis of symmetry is right there. Alright, and so it says draw in the axis of symmetry. We already did that as a dotted line. And here we write the equation. The equation of a vertical line is always x equals some number. Our number is, if you trace this vertical line, where it crosses the x-axis, it's negative 1. So our equation is x equals negative 1. Alright, moving down the line here, it says what point has the same y value as the y-intercept? So the y-intercept, I'm going to put a star beside it. We already found it, is right there. I can find what I like to call, I'm going to write this here, a partner point. It's the point that we use symmetry to find. So look at this y-intercept. It is exactly 1 unit to the right of the axis of symmetry. If I go 1 unit to the left, this is the partner point. And so I'm going to write here negative 2, negative 8. that is the point that has the same y value, -8, as the y-intercept. All right, let's scroll over to the middle. In the middle it says vertex, new vocab word. Vertex is either, we're going to write here, the maximum or the minimum point on the graph. And another big key here for the vertex is that it's the middle. It's the middle point. So our vertex, we know, is right here. We already have it plotted. It is, the coordinates are -1, -9. And in our example, is it a maximum or is it a minimum? In our example, it's the lowest point, so we'll say it's a minimum. All right, next I'm going to go up and fill in the table. Now, it's really important how we fill in our table. What I'm going to do first is, this is bolded right here because the vertex is going to go in the middle. Just like we said, it's the middle point. I can't write the word vertex there. Vertex. So we know the vertex is -1, -9. Now what I'm going to do is I'm going to make sure that my table goes in order. I'm going to fill in the x values first, and I'm going to make them go in order with -1 in the middle. So if I wanted to make those go in order, I want to think of a number line. To the right of -1, I have 0. I have 0, 1, and 2. To the left of -1, I have -2, -3, and -4. Now I want to go fill in my points. So I'm going to fill in this point first, 0. 0, -8 goes there. And then I'm going to go to 1. 1, -5. And then 2, 0. Now I'll go up here to -2. -2, -8. And look already how I have these points repeating. -3, -5. Again, I have this point and this point repeating. And then -4, 0. So our table, when we look at it, should also be symmetric, but it's symmetric up and down. So here's the middle. These are reflections of each other. All right, lastly, let's talk about increasing and decreasing. We're going to write our answer as an interval. So I'm going to highlight the increasing part of my graph in blue. Starting here, going up, and remember I have an arrow. So to describe that increasing interval, we always start at the x value, not the y value. So it starts at -1. It ends at infinity. And that, use parentheses on both sides, that's because it's an interval. All right, decreasing is the other side. I'm going to highlight it in green. So wherever my graph started increasing, that's where it's going to stop decreasing, -1, and it's going to start all the way to the left at -infinity. That's my increasing and my decreasing interval. All right, you should be doing, for practice tonight, homework number 1 in the packet. That will go along right with this notes. Good luck.